everyone, this is lesson 3.6, Theorems about perpendicular lines. In this lesson, we're going to find the distance between a point and a line and use theorems about perpendicular lines to solve problems. This will also be the last lesson of Unit 6, and then you will take your test. So here are 4 different theorems about perpendicular lines. So this one says, if two lines intersect to form a linear pair of congruent angles, then the lines are... So what this means is that if you have a line that intersects to form a linear pair, so think a linear pair is 180 degrees. So you would form a linear pair of congruent angles. Then what kind of angles would those be? Well, half of 180 would be 90. So then if you have two 90-degree angles, then those lines are perpendicular. So this is like if you have a line and then you have another line that intersects it to form a linear pair of congruent angles, then those two angles must be 90 degrees. Therefore, the two lines are perpendicular. If two lines are perpendicular, then they intersect to form 4 right angles. And that can be shown in this diagram here. And then if two sides of two adjacent angles are perpendicular, so if you have a side of an angle, and then you have another side of an angle that is adjacent with this angle, so they share this common side here. So if two sides of two adjacent angles are perpendicular, so that just means this side and this side, then those two angles are complementary. Notice here we're not necessarily saying that these two angles are congruent. We're just saying that they add up to 90. Okay, seems pretty obvious. And then, I guess we have 5. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if you have two parallel lines, we'll give them a marking of being parallel. And if you have a transversal that goes through them, if it's perpendicular to this one, then it's got to be perpendicular to this one. That's what the theorem says. And then the last one, if in one plane, if two lines, so let's make a plane, two lines are perpendicular to the same line. So if you have a line here and you have another one perpendicular to it, you have another one over here that's perpendicular to it. Perpendicular. Then what do you know about these two red lines? They're going to be parallel to each other. So we can also draw parallel markings. All right, so that's all that says. Nothing too complicated. Now the distance between a point and a line is the length of the perpendicular segment. So, back up. What did you just say? The distance between a point and a line, we're talking about the shortest distance here, is the length of the perpendicular segment that connects the point and the line. In other words, from here to this line is a segment that is perpendicular to this line. Okay, as opposed to, say, that one, that line, that would not be perpendicular and it would not be the shortest distance. So when we talk about the distance between a point and a line, we're talking about the one that is the shortest distance, and that is the one that would have a perpendicular line segment from this point to this line. So graph the point and the line, and then, so here's how to find the distance between a point and the line. So you graph the point and the line that you're given, you determine the slope of the perpendicular segment. So you would, you have the slope of this line, and then you would determine the slope of this segment because it would be perpendicular. And then starting at the point, you use the perpendicular slope to draw the perpendicular segment, find the length of the segment created using the distance formula, and round to the nearest tenth. So let's look at an example. So here we have y equals 3x minus 3. So let's graph this line. So we'll go, y-intercept is negative 3. So please get out your graphing paper. Pause the video if you need to. The slope is 3, so go up 3 over 1, up 3 over 1, and then go down 3 over 1. Draw in your line. And draw some arrows. And then this point is negative 3, positive 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. All right, so the slope of our line is 3. So the slope of the segment that would be perpendicular to it would be negative 1/3. So you'd go down 1 over 1, 2, 3, down 1 over 1, 2, 3. Now for the problems that we're doing, the points are going to match up. If they don't, then you probably did something wrong before that. So here we're going to find the distance between this point and this point right here that this perpendicular segment connects to, which is 1, 2, 3, 1, 2, 3, 4, 5, 6. So the distance would be square root of 3 minus negative 3 squared plus 6 minus 2 squared. Sorry, 8, thinking ahead. So this would be 6 squared is 36, 2 squared is 4, and this would be the square root of 40, which is about 6.3. So remember, the directions are that we are determining the distance between the point and the line. All right, let's do one more of these types of examples. Okay, so let's graph the line that we're given. It has a y-intercept of 4 and a slope of negative 2. So go down 2 over 1, and then go up 2 over 1. Draw your line. And then plot this point. 1, 2, 3, 4, 5, down 1. All right, so then let's find out the perpendicular slope. M perpendicular would be the opposite reciprocal, positive 1/2. So we'll go from our point, we'll go up 1 over 2 until we hit the line. And that would hit right here at 1, 2. Okay, so then we're going to find the distance between negative 5, negative 1, and positive 1, positive 2. So we'll have 1 plus 5 squared plus 2 plus 1 squared. 6 squared is 36. 3 squared is 9. This gives us the square root of 45, which is about 6.7. All right, so that's how you do those types of problems. Let's look at a proof. So we'll look at two proofs. So we're going to prove theorem 3.8. That says prove that if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So that was the first one that we talked about on the first slide of the theorem. So given that angle 1 and 2 are congruent, we're given that those are congruent, and we're given that they're a linear pair. We want to prove that, line G is perpendicular to line H. So notice that they put that angle 1 and angle 2 are a linear pair at the beginning. So what can we say if angle 1 and 2 are a linear pair? So we can say if they're a linear pair, then they are supplementary. angle 1 and angle 2 are supplementary. And then since they are supplementary, by the definition of supplementary angles in step 3, we can say that the measure of angle 1 plus the measure of angle 2 equals 180. And then we're also given that that angle 1 is congruent to angle 2. So what do you suppose we could say in step 5? Well, here we're working with the measures of angles, and here we're saying that they're congruent. So in order to work with the measures, we could say that the measure of angle 1 equals the measure of angle 2 because of the definition of congruent angles. Definition of angle congruence, which is something that you are familiar with. Now that we know the measure of angle 1 and 2 are equal, we can use the substitution property in step 6 to substitute out measure of angle 2 here with measure of angle 1. So we know that they are equal. Now this would be a substitution since you're replacing part of an equation, not the whole side. So that transfers down to here. And then you combine like terms, so say 2 times the measure of angle 1. Division property, so we're going to divide by 2 on both sides. Sorry about this. To say that the measure of angle 1 equals 90. And definition of a right angle, so if the measure of angle 1 is 90, then angle 1 is a right angle. And therefore, now we know that for step 10, if angle 1 is a right angle, then by the definition of perpendicular lines, line G and H must be perpendicular. All right, and let's look at one more proof. Prove that if 2 sides of 2 adjacent angles, acute angles, are perpendicular, so this angle here, angle 7 and 8, then the angles are complementary. So keyword here is perpendicular. So if this angle side is perpendicular to this side, given ray ED is perpendicular to ray EF, we want to prove that angle 7 and 8 are complementary. So first, let's say that ray ED is perpendicular to ray EF. Definition of perpendicular lines also falls with angles. So if that's true, then we can say angle FED is, or let's see, FED is a right angle. Now, based off the definition of a right angle, then you can say that the measure of angle FED equals 90 degrees. Definition of a right angle. Okay, now, what are we doing in step 4? We're saying that the measure of angle 7 plus the measure of angle 8 equals the measure of angle DEF. That would just be the angle addition postulate. If you're trying to prove that angles 7 and 8 are complementary, then using the angle addition postulate is going to be a likely step in our proof. All right, now, since you know that DEF, which is the same thing as FED, is equal to 90, you can go ahead and substitute that in. So measure angle 7 plus measure of angle 8 equals 90. Well, if they add up to 90, that means they must be complementary. So now we say the definition of complementary angles. All right, so on your homework, you'll do another big long proof like this, and you will do some more practice with these types of problems where you're finding the distance between a point and a line. All right, have a great day.